even started yet. If the Serval project has a beginning, it's the communications nightmare that was Haiti after the earthquake. The earthquake knocked out practically everything, and there was absolutely no transportation infrastructure to bring in anything new. Knocked out all the roads, the airport, the port, and it was a pretty disgusting mess by the time it was all over. And we wanted to work out what we could do to help mitigate that kind of problem, preferably using all of the hardware that they already have. So try to picture what it might have been like. You've just escaped from a crumbling building, you pull out your cell phone, you've got no coverage, and you need to tell people you're alive, and you want to discover how everyone else is, and then you've got to cover the basic necessities and try and pull people out of buildings and all of those kinds of things, which take coordination, which you can't do because you don't have any communication system. So we looked at all the types of things that we could try and implement. Obviously mobile phones are everywhere. You're probably going to have one in your pocket, and we obviously then need to find a solution to use your existing phone number. If we handed you a phone and we just randomly assigned something to everybody, you wouldn't be able to call each other because you would have absolutely no idea what numbers everyone had been assigned. We need to have absolutely no central control. The phones have to be able to self-organize and discover each other and do everything else with absolutely no other infrastructure. We have to assume that everyone's going to wander around anywhere, and it should be freely available to implement and install and modify. Did I skip one too there? Only there. So in our first year, we got a bunch of volunteers together to help get us off the ground. We ran a couple of student projects that to implement a few new features. I seem to have skipped too much, haven't I? This is not going too well yet. Okay. After Haiti, first prototype, we cobbled together on an Android platform Batman and for mesh routing with the Android Wi-Fi tether application to give us the ad hoc wireless mode. We put in asterisk, we wrote our own dial plan so that we could find devices on the network similar to the way that ARP works for IP addresses, and SIP-Droid's UI for the front-end calling. And we got some funding from a few different sources based on the media coverage that we've accomplished out of that. Went kind of viral in some areas. Yes, then the first year after that, set up a company, got some volunteers together, got a little bit of funding, and started trying to improve the software. The source is now available online at GitHub. We've also refactored some of the internals so that we can operate our software without wireless ad hoc mode and without root control. Obviously, if you're changing the routing table, you need root access. But even here at Linux.conf, you can walk around with a phone on an unrooted handset using the LCA provided wireless and talk to each other. We've added support for text messages, but we don't have our own front end. You can install SMS Droid and Web SMS to provide the UI layer, and all we do is the transport at the moment. But we will be providing our own UI in future, and perhaps at that point also integrating a voicemail or push-to-talk functionality. Version 07 is on the market. It's a point-and-click install now rather than the rather long 3-page script that you had to follow, which included going to the command line to configure your phone number. But we still have some issues that we will always face. As I've said, the handsets may not have root access at all, and there's actually no SDK support in Android to get the Wi-Fi radio into ad hoc mode. So what we end up doing is loading the Wi-Fi driver ourselves, but then every handset is effectively a different Linux distribution. We have to find the firmware, find the driver, work out what module parameters we need to pass to it, get it loaded, and that's a nightmare. So, so even if you have root access, we might not be able to get Wi-Fi to work. And then we get to ad hoc Wi-Fi, which has its own set of issues. two devices, two different manufacturers, you set them up to have the same SSID, and they won't talk to each other. It might depend on which one you turn on first, and then they might synchronize properly. If they get too far away and then come back together again, they may have changed their internal cell number, and they just won't merge. And there's also issues with timing, synchronization, as similar kinds of problems. You might be able to transmit broadcast packets to each other, but the unicast packets with the BSSID acknowledgement don't go through at all. When you're sending unicast packets and you get slightly out of range into interference range and beyond, and you're still trying to send packets that way because that's where your routes are going, ad hoc Wi-Fi can retry up to 7 times. If you're out of range, that cuts your bandwidth to a 1/7. And every single packet in the network queue queues up behind them. So you won't talk to the phone right next to you because you're trying to send a packet to someone who's out of range. Completely screwing up the mesh routing protocol. Now, we're not going to sit idly by with all these kinds of issues we found. We're sending one of our representatives to the IEEE to try to bring these issues to light and face them and fix them in the next standard. Which is actually why I'm here today. She would have loved to present, but she's in America at the moment. At the mesh routing layer, you can have all kinds of problems because we're using the routing table to send unicast packets. So the only thing you've got left to discover peers is sending broadcasts. But broadcasts and unicast packets have very different characteristics with the way they're transmitted, leading to a problem where you, through broadcast, might think there's a working link, and you send a unicast packet and it never gets there. Yeah, and we can't, because we're just using Linux kernel routing, there's no detection of whether or not that unicast packet is arriving and whether or not we need to change to a new path because this path is broken. And every time we try and send it, we'll send 7 copies of it, chewing up the bandwidth space. After a disaster, you may not have enough battery power to keep the network going, you may not have enough devices to get complete coverage, and these phones typically have fairly limited Wi-Fi antennas anyway. That it's quite difficult to set up a multi-hot relay test just using mobile phones because you turn the phone one way and all the signal's going over here, and you turn it another way and all of your network paths have to be rebuilt from scratch. So in a disaster, we absolutely cannot rely on having a complete end-to-end network connection between two people as the only means of communicating. So while our software will use that to do a live call, we need an alternative. So we absolutely must have delay-tolerant store and forward protocols for getting messages from point A to point B. We might have some devices that can only be reached some of the time as we have an access point turning on and off and other devices attaching to it as the only means that they can actually communicate. And we must guarantee that the first phone we get into the disaster area is enough to get every single phone on the network, to install it on every phone and to establish communications. We would like our software to spread a little bit like a virus. Poor name for computer software. So instead we're going for a fungal solution called a Rhizome, which has threads under the ground, and if you cut it into pieces, each one of them will keep on growing. At the moment, our simple prototype is just using a web service on a little web server on each phone, providing a list of files, and we discover all of our neighbours and fetch their list, and if we don't have the file yet, we'll download it. But we will be doing this a little more efficiently as we invest some more time in development. Yes, our prototype version. We can also, with the files we're transferring, transfer a copy of our own application and install a newer version. We can update the software in the middle of a disaster after we discover that the phones in that network aren't supported. We might get a log file back to a central server, somebody analyzes it, has a quick poke around, changes the software, sends the update across, suddenly they can do ad hoc mode again. We don't have any encryption yet. Everything's horribly insecure. We flood files all over the network infinitely, but it's just a working prototype. Proving that we can do it, there's probably 2 or 3 PhDs worth of study in trying to work out efficient ways of spreading files towards the person you intend it to get to when you don't have a complete path and you can't actually work it out reliably, which is going to be the next device to get in range of them. So, we'll divert here slightly to 2 phones as an example. We have one here that is running our software. It is on a mesh network that has another phone on it. There's somebody in the audience, I'm guessing, who's already been playing around with our software during the conference, which would be over somewhere, be ringing about now. Don't answer. Turn it off, please. Anyway. Wasn't quite expecting that. Yes, anyway, right. And we have a second phone over here that does not have our software at all on it at this point. No, I'm not trying to open that. Go away. So we can send it via Bluetooth to our second phone, which will be, oh dear, there's a lot of devices in here, isn't there? There we go. And we get the accept of the file and a nice transfer progress bar with our 2.4 gigahertz devices in this room. That might be a little slow, but it will get there eventually. Now that's using Samsung's Bluetooth stack on these 2 devices. Not every Android phone can receive a file by Bluetooth, which is a bit of a nuisance. We'd wish it was better. We do have an alternative though. We can turn one of these phones into a hotspot, a personal access point, provide enough instructions to get the second phone to connect to the access point, go to the web page, download the APK, and install it. But this is easier for users. And these screens also time out quite quickly. There we are. So we have our software copied, and we can go and install it. We do have a rather nasty looking set of permissions because we're trying to hook into all of the phone services, Bluetooth headsets. We need to unlock the screen so you can answer, and so on. Yes, we can potentially make phone calls and charge you SMS messages and so forth, and internet access and all those kinds of things. Our source code is online. We hope that people will look at it and see if there are any vulnerabilities and so forth. Get a bit more trust that we're not doing anything unexpected. Our installation process is unpacking an entire Asterisk installation there into the file system. Yes, we have root access. It's found out that it's a Samsung Galaxy, trying to work out if the Wi-Fi is turning on. And it should come up eventually. In the meantime, oh, that's not going to work too well if I try and pull that cable out, is it? Ah. Yes, so we have a phone that we can set up its phone number, go through our nasty disclaimer. Don't use this in Syria if an oppressive government might try to kill you, basically. It's not encrypted, it's not secure, people can find you, etc. Now what we can do, once we've got these phones in the network, get back to the main focus of the talk, is we can start transferring files between the devices. And as an example, smile. There we are. Share that, copy it via our software, publish the file name, and within around a minute, it should arrive there. All without servers, all without infrastructure. Now, obviously, as each phone is turned on and off, these files will propagate around the network. When you wander into range, we can also send text messages using this interface. No, I don't want to send it to that phone number. I need to send it to that one. And we have a message arrived. And that just goes straight into the system message log. Whoops. And there it is. That would be real-time transfer because we actually have a real-time connection, but if that fails, we'll write a file, copy that across the network, and eventually get it to the recipient. I'm rushing a little too much, aren't I? Moving forward, obviously, we need to do some network security. We plan to encrypt every packet to every person that we're sending it to, and every message and potentially files that you wish to send. To do that, we need to worry about secured key exchanges to try to establish identities. We want, as I've said, our own text message interface that we will also allow for voicemail and push-to-talk style queuing, that you could send a message to a group of people on a network as they're wandering around, getting into range. All of the files will be available and they can be played. Using codec 2, as David Rowe was talking about earlier, we could fit about 8 seconds of voice into one network packet and transfer voicemail quite efficiently. Public microblogging, Foursquare, GPS, coordinate style checking, where people are, what kind of incident, points of interest on a map. Lots of different use cases that we're planning for. We would like some more help. While we've got a few people helping us out, we don't have that many people focusing on developing new code at this point. Welcome to, even if the only thing you do is test it on your handset before every major release to make sure the software still works for you, we can't test every ROM. Every Android ROM is effectively a separate Linux distro with Wi-Fi firmware binaries in different places and so on. While we're here at Linux.conf, I would like to spread this nightly build that I've got here virally across our mesh network, as has been already happening with Rob Thomas championing this software. We've had it running on a tablet, we've had it running on quite a few other devices. At this point, are there any questions? You have a microphone or just yell?
Is there any way you can get 3G radio to work? Like, because there was that news that people had open source 3G and as well as microcell.
Yes, 3G radios in a disaster. Yes, we would like to have OpenBTS. It requires hardware, that's half of the problem. Our focus is on, let's make something that works using what you have. If you've got, at the moment we focused on Wi-Fi, on Android. We probably need to do communications via Bluetooth, and Wi-Fi Direct is pretty good for peer discovery, so you can work out who's around you before you've even connected to them, if you've got it. We don't have a port that with any ice cream sandwich features yet. Back to the question again, distracted. Yes, we'd like to integrate with OpenBTS. They're just running asterisk, and our dialing number plan is just an asterisk plugin. So we can already, and I did a test back in Washington in June, place a call from a GSM phone to OpenBTS across an automatically organising wireless mesh network to a Serval phone without any configuration. Going the other way is a little harder. because we have to be able to read their database and deal with the phone request. And we do have plans to implement that.
The other thing I was going to say is there's really cheap ways to their Wi-Fi antennas. So Windows can type make out an alpha basically. So that can be built into the task area.
Certainly. I mean, if it's there, it'd be great. If it's not, we have to cope, which is what the focus is at the moment. Yeah, it'd be lovely to set up a pirate or third-party GSM network. But anything else over there? Yep.
Two things. First, if you could shout, I'd really appreciate it. I didn't hear the question. I heard about half of the answer.
Sorry.
So raised voices would really help. The other thing is, I saw passing mention about power, but I wonder if we could just talk about the implications in that a bit. I was playing with Serval this morning, and just about blew through my battery in less than an hour. I can tell you from working in the developing world for quite some time that recharging the phone is a non-trivial issue, even ignoring hurricanes, natural disasters, what have you. Having been through them, I can say sometimes we go days without a recharge. And the prospect of having to, just turn on for the 10 minutes and try and get somebody really reduces the effectiveness of the mesh itself, the network as a whole. So have you given much thought to that? And if so, what do you propose?
So summarising, if I can, battery power is an issue. Certainly it drains through. Our current implementation drains through your battery fairly quickly because we're doing a little too many things in the background. Developing world, that is an issue, going to be an issue. One thing we have noticed, if you go out in the middle of nowhere and you have your GSM radio on, you'll probably be transmitting at about 4 watts to try and find the nearest cell tower. Putting your phone into flight mode and turning Wi-Fi on uses less power than that. But certainly we're running a certain number of things in the background that are polling and keeping the CPU awake a little too much at the moment. We will need to work on efficiency. We also have some plans to synchronize clocks and turn off the radio in sync with each other periodically so that we can have a duty cycle with less than 50% power. But these are things that are in ongoing investigation, and obviously a lot more work is required. We wouldn't be able to do those things with the current state-of-the-art mesh networking. We need a little more control of things. Obviously we'd have to customize them or completely write our own, which is on our roadmap. Anyway, next one. All right.
So I gather you need root on the phone to set up the networking?
You only need root if you want to use ad hoc Wi-Fi. The software works connecting to access points.
Right.
Obviously, ad hoc Wi-Fi is better because you can do multi-hop call routing, provided there is enough coverage and enough devices.
Yeah. And then, so you're doing mesh networking still, or
that's mesh networking, yeah. Yep.
Does the ice cream sandwich VPN API help you at all on top of unroot phone?
It could be an interesting way of implementing a user mode mesh layer, but we'd still need root access to put the Wi-Fi driver into ad hoc mode. Yeah. So then if we can avoid changing the routing table in Linux, then we could get past that.
Is there anything more that you want from the Android platform that can help you?
Yeah, let me count the ways. Probably a few things. I can't think of anything off the top of my head. Sorry, I haven't been repeating the question again. Would we want anything else in the Android platform? Yes, we would. A supported interface for ad hoc Wi-Fi. Obviously, we'd want a better interface with the actual standard needs to be improved, but that's a side issue. Sending text messages. We can't prevent the messaging API from sending an SMS, whereas we can intercept normal phone dialing and replace it. We can't do the same with SMS messages. So effectively, SMS Droid has to write their own complete front end from scratch to do it all and reproduce it. But then we're going to do voicemail, which wouldn't fit into the Android model anyway. Can't think of anything else right now. Any other next question? Hands.
If you've got it running on any other platforms other than Android, like a standard laptop or a PC?
We haven't got a point-and-click install. The tools, you could compile something together because it is just asterisk with a custom dialer at this point. We plan to support other platforms. We would like to support other phone platforms as well, but we don't have the manpower to do so at this point. Certainly you could set up a Linux laptop, join the ad hoc mesh, install asterisk, get the dial plan configured, and you could then send and receive calls with whatever your favorite SIP client is. Yes?
It seems that you're very early on voice communications, which...
It's certainly what we started with, voice communication.
Yes, obviously needs full-time Wi-Fi access and whatnot. I'm sort of thinking in the middle of a disaster, is not an emergency text messaging type service more important? And then maybe the phones or the power requirements of the phones could be addressed by just synchronising them and bringing them up every 15 minutes. The idea of trying to keep a Wi-Fi network up and running while all your cell towers are actively moving around the countryside.
That's right, and that's partly what we've done. The focus is on what I'm talking about here is transferring SMS messages opportunistically as devices get closer together. So yes, we can do text messages, and we are focusing on that because we saw it as a big weakness in what we were doing before. Yep.
Have you had any thoughts on the integrating with other emergency communication systems?
Are we going to interface with other emergency systems? We would like to interface with satellite-based text messaging services. We've got a satellite BGAN terminal that we can set up to link you back to the normal PSTN through a gateway. We're thinking about all those kinds of integration aspects. I can't say it's as polished as I'd like, but it's certainly possible.
We're actually forming an active relationship with one of the larger humanitarian response organisations to basically specifically to meet their needs, and it involves satellite integration and a whole pile of other kind of things in that space. So we're thinking about all these things. We don't currently have the manpower to do all of them at once. If anyone wants to help out.
So specifically, it was more about integrating with ham radio, emergency stuff.
Well, if we could interface with ham radios, that'd be great. We do have some plans to build a custom Android platform that you could plug different radios into, but you could always use our software on the mesh network to receive messages and have a ham radio either repeat them manually or semi-automatically across another interface. It all depends on whether or not you want to provide an unfiltered gateway to the ham radio spectrum.
We don't.
Because, exactly, the general public may completely flood it with useless messages that you don't care about.
Right.
Yeah, I don't think it'd even be very demonstrated.
And probably not, because they don't have ham licenses, they can't be controlled sending message.
Yeah, it would mostly be hams dialing up hams.
But choose for emergency, that stuff collapses.
But ham dialing hams could possibly be semi-automated.
Yes.
Yeah. So we could write something that pulls the message out of our system and they go, okay, send that. But it all depends on requirements and time and... Yes, we've got a name of another person who's alive. I'll just add it to the list for the next message.
Yeah.
By the way, we do have that stuff.
Yeah, the hams already have some things already, yeah.
And certainly more interaction with the ham community generally is something that we're keen to do. And then one of the baseline things is actually getting an addressing scheme that can actually work and be auto-configured regardless of what the transport you're using underneath is. So IPv4 is a small IPv6 actually isn't on all the phones that we're using, which is a big problem. So that's out. So we're using public keys in elliptic curve for key space as a network identifier, and we address abbreviation and prefixes so that you're fixing reasonably sized packets.
That's the roadmap.
Where we can.
When we write our own mesh transport, we will be using public keys as identifiers so that we can find you. Whether we map those into IP6 packets for traversing segments of the network is all up in the air. But yeah, none of that's written yet. Well, none of that's
There's some half-baked stuff in the oven. Cool.
Well, I think everyone has things to say. Slightly early. Any more questions, discussion? Bluetooth and Wi-Fi, they use the same frequencies, slightly different communications. I think some versions of Bluetooth actually jump into Wi-Fi mode to send packets, so they can send them with a faster transfer rate spec. But it's lower power. If we're using Bluetooth and we can establish that we have a link between devices, we can turn the Wi-Fi radio off when we get that level of control and understanding. That we'd need a lot of smarts in the mesh routing layer to be able to do that. And how do you then, you would still want to negotiate that some subset of devices turns their Wi-Fi radio on to discover devices that don't have anything else, or for where the other issues are happening. Yes?
Just wondering, is this mainly targeted at the recovery, people coming in for recovery, or is it that you're also looking at it for maintenance communication?
Having built this system, yes, we do look at all kinds of other use cases. Search and rescue would be an interesting use case. Red Cross are interested if we can meet their requirements for house-to-house data gathering, keeping track of where their team is. We're looking at all sorts of things like that, and rural and remote communities immediately spring to mind where they're underserved. Udna Data, for example, has internet access but no cellular coverage. We could provide that a little bit of extra flexibility in the community. Well.
Okay, thank you everyone. This is a gift from the LCA this year.